Hi everyone, my name is Eric Foley. I'm here to talk to you about a major environmental flooding that happened in South Africa around December 2025. And it's currently happening and it's currently on its pace to recovery, I guess, as of right now. So, floods in Mozambique. So, specifically, we're going to talk about the southern Mozambique or the Gaza and Maputo provinces, with Maputo being the capital of the capital of Mozambique, which if the Maputo province is also one flooded, then if the capital is underflooded, then it also prevents a huge risk there with, leadership wise. And so other areas, major areas, the Limpopo River and Basin and the Inkamani Basin. Um, Capital city of the Gaza province, Zai, and the Messenger Dam, which is on the Elephantine River, which connects to the Limpopo River as it's going out into the Indian Ocean. And so as you see down here by the JBA, we see the Zambi and Limpopo regions right there, basins. That's also huge. Was a huge part of it that's flooded right now. And of course, you see debris, branches. You see sediments, you see dirt, you see rough waters. All very not optimal conditions, or I guess not normal conditions for uh, Mozambique. Context: how this kind of happened. Basically, in the Pacific Ocean, you have normal weather patterns, and except when those normal weather patterns differ or become opposites or something like that, you get El Nino and La Nina, which are phenomenons that don't, I wouldn't say are like every single day, but they can last very long or they can last very short. And so there's not really a cycle to them, they just happen. And so basically, we're going to be talking about La Nina, which brought in warm moisture from the Pacific Ocean westward across the Indian Ocean, and then it ends up in Africa, or for our circumstance, Mozambique. And so that warm moisture brings in warm water, water vapor. And then as it cools down, it condensates, and as it condensates, it gets heavier, and then eventually gravity just brings down rainfall. And that's just the starter of one of our problems. Um, this is a massive crisis down there. Well over hundreds of thousands of people are in have been relocated or even affected, at least in bare minimum. Um, for our sake, this is the perfect example of what happens when nature and ecosystems sort of shift out of balance and they don't and options are not optimal for normal sustainable living, I guess. All right. Biogeochemistry. So from this standpoint, the amount of rain that happens as it soaks up the soil, um, as the ground becomes super saturated, the ground can no longer hold water, so the water just stays on top. And not only when the water stays on top does it increase runoff and just takes the sediment off the top and just rolls it by. It just keeps going until it's relocated. Um, it also prevents chemical change in the soil's state. So it goes from a aerobic to an anaerobic state. And so that's when the hydrological cycle um, is pushed beyond its max to where the soil can no longer uh, hold hold its own. And so when the soil can't hold its own, the plants need some other source of food or energy like oxygen. And so since there's no oxygen because it's flooded, it has to revert to other important areas. So number one, nitrogen. And so is nitrogen is very used for plants as it is a natural fertilizer. Um, and so when there's nitrogen in soil, and of course, um, the soil strips off the oxygen off the nitrate compound, and that releases the nitrogen. And so when nitrogen's released, it becomes a gas or it flows up and it goes into the atmosphere or does whatever it's going to do. But the soil eats the oxygen and then nitrogen flows up. And then when the nitrogen flows up, when the rain stops, so the soil goes back to normal, there's no more nitrogen. And since nitrogen's a fertilizer, that means the area of the land is no longer as uh, as plentiful or as fruitful as it should be. Maybe not fruitful, but like as efficient as as it should be. So it's called a denitrification. And since plants need nitrogen um, to operate, it kind of screws up the future generation of crops living there. So this goes back to agricultural revolution when they started putting uh, nitrogen nitrogen housing plants into their fields to recuperate and re-give or give back some of that nitrogen back into the soil so that it can be arable and farmable for future generations. Um, the second process is that soil uses iron for energy. And so when soil uses iron for energy, the phosphorus on the iron becomes detached because the soil is taking the oxygen off the iron. And that creates oh, I guess it creates like an imbalance in the magnetics or electromagnetical field between phosphorus and iron. And so phosphorus leaves and goes back up into the water and goes back into the soil as runoff is happening. And so that causes eutrophication or eutrophication, in which it gives algae blooms. And although algae blooms are naturally occurring and they're not bad, but an excessive amount as a lot of rainfall and all these plants just giving up the phosphorus, it can be very bad because then it's just an overwhelming amount of algae. And that can also come to bacterial or other diseases. So that's sort of the biogeochemistry of the event. Um, you see soil starts to prioritize itself. In this case, it gets rid of the nitrogen, it gets rid of the iron, it gets rid of the phosphorus, and then that just it it prioritizes itself is a little bit weird because it's not really prioritizing itself, but it's more like just it doesn't care about the other things. All it needs is oxygen. And so if we look at this chart here, this is a hydrograph of a typical flash flood and that of a flash flood with saturated soils, as you see up top. So there's a normal flash flood and discharge and rainfall event is, quite big, but the runoff is not as bad. Now, when you compare it with saturated soils, you see this up here is how much water is actually above, is actually being, is actually, I guess, flooded. And so it's not being absorbed by the soil. So that's you could see saturated soils, they don't hold any more water because all the water is it's too much water, so it can't be held on. So yeah, moving on to our second topic, we're going to talk about geology. And we all know water is a very good or a flow of water is a very good erosion. You see smooth stones from the flow of water, the dried up Colorado River. You see the sedimentary, or you see the layers of rock in the Grand Canyon, and of course rivers or you know uh, I guess like cool ideas you see in water parks or something like that. So this would be the geology, and so um, in late January, the dam was forced into emergency release, resulting in a lot of a lot of flowing water, a lot of pressure. Um, it can be measured at 17,000 cubic meters per second, which is quite a lot of water, obviously. Um, I'm not sure if that was the exact measure, but it's like more like what it has the potential to be. And so this high velocity discharge, puts obviously a lot of immense pressure on riverbanks, and it just erodes the riverbanks and makes them, completely obsolete. And so as riverbanks failed, you see not really landslides, but you see like all this sediment just going straight down a river, and it's just literally just ripping through, carving a new river, I guess. So if we look at these images here, let me move myself. Look at these images here. This is December 17th. This is before the floods. You can see the dam. That's the Messenger Lake, and you see the dam right at the edge, and you can sort of see the lake as it goes down. Here's the Limpopo River, and then here's the Elefantes River that comes down here. You can want to see it on the side. And this is in January, and you can just see the amount of flooding in between these two. I think this is a little bit more zoomed in, but you can definitely see the amount of flooding and all the rich greenness is just being stripped away and just going pouring into the ocean. Yeah, you see the natural river state before the rain and then after the rain. you see it's significantly more flooded. All down here, that's certainly thicker. You see right here, it's you can't really you wouldn't even be able to tell probably. You'd probably say it's like a marsh or wetlands. That just looks like just complete utter failure of just water. It's almost like they're connected. Well, they probably are actually in that photo. And so it just shows how all this water pressure can really reshape a coastline or reshape a river, reshape a riverbank, causing lots of destruction, messing up ecosystems. Now, another take would be this was this was from another flood in December 14th to December 2015. I don't think that's right. I think it's supposed to be January 2015, excuse me. And so, as you can see, all this sediment from the floods is in a different area. This is a little bit north of Gaza and Quito provinces. But as you see, all the sediment from this floodwater is just pouring into the Indian Ocean. Excuse me. There's just so much water down here, flood water, just absolutely destroying banks and pushing sediments way past, just shaping the coastline. And then versus a month later in January 2015, you can still see even then there's still a lot of sedimentary deposits going into the ocean. Maybe not as much, obviously, but it's still a decent amount. It shows how much I guess it could take for these ecosystems to recover. Again, before and after, and then again before and after. Let's see. Now our final topic is ecosystem services. And so the wetlands of the Limpopo Basin provide a service, acts as a natural sponge. So it takes some of that water and, it's allowed for water to recede. It won't be too dry, allows water to expand or exceed, and it won't be too wet. But unfortunately, in this case of flood, the wetlands just are completely overwhelmed and it's reached its limit. And so this collapse of the natural defense um, has led to over millions of acres of farmland just destroyed, um, crops destroyed. It's a complete total loss for not only community, but for, I guess, future generations as well. So all these people living on crops, their farmland is now destroyed. And so, yeah, that's an ecosystem service. And so, um, other major ecological disturbance, you can consult biodiversity. Habitats are destroyed, so wildlife are kind of mixing, as you can see in these flooded areas. Flooded areas, um, obviously going to be some animals in there, some dead carcasses maybe. That also just prevents this. That also just starts diseases, and snakes could be in here, crocodiles, as the capital city of the Gaza province, Zagzag. I'm sorry if I butchered that. Um, they've actually experienced, I think, a couple of crocodile attacks. This is just a complete, it's just wasted. This is more modern. This is probably more in the city, but you still they're walking around, but it's still completely flooded. That woman's up to her knees. I mean, that's rust. What if you cut your foot? It's all just a bunch of bad scenarios. And so these human engineering feats are roadways, sewer systems, sanitations. It can't be properly sanitized, and it just shows easy ways for ecological, I guess, like an ecological uh, disaster. Um, you can even see here all the sediment. I don't know if that taken away under the road track, but I'm not sure if any train can even ride that if there's still water like clogged down there or clogged water on the other side. But obviously the rain has had a toll on the road, just wiping away the foundations. And so it's a complete and utter loss. And so flooded urban areas, uh again with the dead carcasses, there's an increasing like disease like cholera, malaria, um, probably some waste diseases also included in there that I can't remember right now. Um, but it really just shows how destruction of ecosystems, uh, I guess primarily farmland is probably the most impactful for this, as there are just farmland is just destroyed. And then even if it does go back to normal, again, all the fertilizer, the nitrogen that I talked about, um, that's all just been destroyed too. So yeah. And then ending thoughts. Um, in conclusion, it's not really just a weather event, but it's more of just like a catastrophic disaster. So it is when you say international case, um, they have actually the government has actually called the help of the UN, and the UN is actually helping currently. Um, there's a lot of stats that you can look up for Mozambique and how many kids, and I pulled some of those, um, such as the diseases, such as farmland, such as people affected. So yeah, roads are broken, roads are flooded, people are isolated, crocodile attacks, I guess very few, but still crocodile attacks. And so yeah, it just shows the ruthlessness of Mother Nature and how we don't really have control. And so I believe that is a third world country. So obviously third world countries have it harder than first world countries and they aren't as prepared as we should be. But still kind of just shows maybe a step in the government or maybe a step in the UN helping out all these poorer countries, so that when something does happen like this, because we can't control Mother Nature, when something does happen like this, it shouldn't be as bad or as devastating. Because the farmland, again, that's probably like one of the biggest points. All their food is just destroyed for the next couple generations. So I'm sure the UN will give them food, but growing their own food should be a lot tougher. Um, for geology, it shows the pressure of water and how land is not static, and it can literally reshape. Let's just go back, even just go back here, literally just reshape this entire road. And of course, probably has some difficulties there with the roadway. Um, for chemistry, nutrient flux, water runoff, that just strips away that topsoil, that strips away the nitrogen, that strips away the phosphorus, and leaves the soil unfarmable a couple for as long as until it can be fixed. Um, Also big things like climate drivers, La Nina. That's also you could call that biogeochemistry. You call that maybe just a weather something, and just natural occurrences. So, and then lastly, ecosystems. Nature services have a breaking point. So again, I guess like everything can't be in a unity. Um, Even now, Florida hurricanes. I know I used to live in southern town, relatively small. We lived on the river, and remember just seeing water flooded during I think Hurricane Milton, and it just absolutely destroyed um, our streets and our and people's houses are just flooded, 15 foot of water. Multiple people were evacuated. So it can really showcase the strength of uh of these disasters, and it showcases the strength of, or I guess the lack of order that can happen. So of course you have fishes swimming there, crocodiles, manatees. You don't want a manatee end up in a dumpster or something, because it's floating down. So it's really a big concept to look into. And I guess our only way to look forward is to build our own scientific, I guess, hypotheses or ties and build more resilient infrastructure and protect natural buffers, like maybe for the wetlands, maybe reservoir, separate reservoir, in case things go south or another thing. But yeah, if ecosystem services um, can't be helped out by themselves, over them and it needs human intervention, then that shows a sort of like a step above natural buffers and shows how like us as humans, we should also be acclimated and prepared for Mother Nature. So yeah, thank you for your time. Um, yeah, thank you for your time. Have a good night.